In this tutorial, I'm going to tell you all about stereoscopic workflow inside Cinema 4D R13. On the screen at the minute you can see a stereoscopic image. This is one intended to be used with ANAGLYPH glasses, which are the pretty cheap glasses that you see that are typically red on one eye and cyan on the other. And when you put a pair of those glasses on, this image should appear to pop out the screen at you. If you take those glasses off, if you haven't got a pair indeed, you can see that this image has a little bit of cyan on various bits and a bit of red on the other side. So what it's basically doing is presenting two images for you, and by putting on the glasses those images are combined or merged to create a 3D image, and then it appears to pop out the screen at you. So what we're going to do here is, first of all, I need to tell you about the technical things behind stereoscopy. And when you understand those, we can go into Cinema 4D and I can show you how they're set up. But you need to understand a bit of the lingo first and understand the different solutions. This tutorial is aimed at the complete beginner, so you don't need to know anything about stereoscopic workflow for this. It won't go super advanced though, so there are stuff that you basically need to learn after this if you want to really get into stereoscopic output. But this should give you a good grounding. So let's have a look. First thing we need to define is, what is stereoscopy? It's basically a technique for creating or enhancing the illusion of depth in an image, and it's achieved by presenting two offset images separately to a viewer's left and right eyes. The images are then combined by the viewer's brain, giving the perception of depth. Hopefully that sounds familiar, because that's exactly what happens in real life. That's why you've got two eyes, and that's how you judge depth. The two slightly offset images coming from the right and the left eye are combined inside your brain, and that tells the brain how far away something is, whether it's big or small, that kind of thing. The trouble is, when you're viewing on a TV screen, is that information isn't there because you're viewing stuff on a flat screen, so it's very difficult to judge the depth. So stereoscopic output is all about trying to recreate that illusion of depth, even though it's sitting on a screen. So there are different ways to view that, many different solutions. Some of them are to wear glasses that combine the separate images from two offset sources, or wear glasses that filter offset images from a single source separated to each eye, or have the light source split the images directionally into the viewer's eyes. That one doesn't require glasses. And each of them require different styles of rendering, different solutions, and the good news is that Cinema 4D R13 supports them all. So we should probably have a look at these different solutions and the pluses and the minuses, so you understand all the different options out there, and then you can choose what's best for you. So inside Cinema 4D, basically what happens is there's now a stereo camera, and that's set up for a left and a right eye, and then you can output those images in different formats. So you can have individual channels, for example just the left and the right eye. You can have ANAGLYPH, where Cinema 4D will merge the two images and give them a filter colour, so in this case red and cyan. You can see that at the top right. Interlaced, which is very similar but gives slightly better colour reproduction, or side by side like this. So they're the different solutions. So Cinema supports all of those, and we're just going to go down now and talk about the first one. So ANAGLYPH, so that was the one with the red and the cyan, the very first one that we looked at on the screen, and that's the most well-known method because it's been around, used in movie theatres since the 50s. And images colour information, they separated to two colour glasses, and in the old days they were red and green, and today they're most commonly red and cyan. The advantage is the glasses are really cheap. You can get them for pence or cents. You don't need any special hardware either, so you can just print out an image or put it on the computer, give someone a pair of those glasses, and they should be able to see the image. The disadvantage is the colour range is really limited, so that's one of the reasons why stereoscopic 3D movies didn't really take off that well, because you're looking at pretty basic colour depth or colour range. So to solve that, and more recently you've had the shutter system come out, and that's the current most high quality method out there. It uses special glasses, and the glasses are synchronized with a monitor, and basically the monitor flashes up alternate images for the left and the right eye, and as the left eye is showing its image, the right eye shutter closes, so the right eye doesn't see that, and this is so fast, you know, you don't notice it, but it basically means the left only sees the left images, the right only sees the right images, and they're combined together in such a short space of time that it gives the illusion of depth, which is exactly what's needed. The advantage is best quality, true colour reproduction. The disadvantage is it's expensive. Special hardware and monitors must offer at least 120 Hz to view them. Interlaced is another method. This requires a monitor with a polarization filter and glasses with polarized glass. Both images are coded into a single image, so the left eye has all the even and the right eye all the uneven lines, so the resolution is halved. So you're basically looking at a merged image, but they're in between lines for each eye. The advantages of affordable glasses, they're not as cheap as the ANAGLYPH glasses, but they're still pretty affordable. Good colour reproduction. Disadvantages, special monitors are required and the resolution isn't as high as the shutter method. Another solution is side by side. This is where the left and the right images are switched and squeezed into a normal image size. The terminal device eye, the TV for example, must be able to decode these double images and display them sequentially, most commonly in combination with shutter glasses. Disadvantage is reduced resolution. It's expensive technology and you need special hardware for it. But you often can see that used where the transmission of information is important. For example, a TV broadcast, it's a little less demanding on the transmission. The other solution, or there's many other different solutions which require more channels outputted. This general term is classed as AUTOSTEREOSCOPIC with Cinema 4D. So basically with Cinema 4D you can have any number of views that lie within the range of the defined eye separation value, and they can be rendered for the left and the right eye. So this kind of makes more sense if we look at a picture. So this on the left is a traditional 2-channel stereoscopic setup. So you've got channel 1, channel 2, left and right eye. On the right is an autostereoscopic setup with 5 channels. So channel 1 is the left eye, and the one at the bottom, the right eye, is channel 5, and then you have the 3 cameras in between. So far so good, but it's not quite that simple. What to look out for? Screen size really matters. What works really well on your little laptop may not work well on a big cinema screen. So there are things you need to think about and calculate. I'm not going to go into that because that gets quite technical. If you want to know about that, just search online for stereoscopic screen size recommendations or something like that, and you'll find lots of information about it. The distance of the viewer from the screen is also important. So if you have somebody near, the effect that they will get can be quite different to somebody very far away. The high contrast in a scene, so if you've got a scene with high contrast, that can cause ghosting. You don't want to cut objects off the edge of a screen either. So if you've got an object popping out, it can really confuse things if it's cut off at the right or the left side of the screen, or the top or the bottom. So you want to have your 3D effect ideally centered or well within the boundaries of the screen so you don't confuse the viewer. You also don't want to shift the parallax settings too fast. So the parallax refers to how big the perception of depth is in the scene, and if you want to change that quickly to go from lots of things popping out to not many, that can really make for uncomfortable viewing. You also want to avoid exaggerations, so constant objects flying into the viewer's face doesn't do good things for the viewer because it's quite uncomfortable to get this effect. Remember, you're simulating something here, so you need to be careful because it takes the brain a little while to process this, and the greater the effect that you go for, the more uncomfortable it is to view. You also want to consider the amount of separation between the offset images. So the wider that separation, the greater the perception of depth, but the more uncomfortable it is to view. Generally, our eyes don't like to view things that are greater than 6.5 centimeters apart, which we'll explain in a minute. So what we're going to do now is jump into Cinema 4D, and I'm going to explain that stuff. So hopefully you know the basics now, you know the different solutions out there, you know the different techie terms, and now we're going to show you how you set it up in Cinema 4D. Now the good news with Cinema 4D R13 is they've really nailed this, the programmers. It's really done nicely. You've got full support for most stereoscopic solutions out there, and the way you access them is very, very simple. So in this case we've got a scene. I've just hidden the environment here. If we hit play, we just see it's a rotating drill piece. So there we go. And to see that stereoscopically, you don't even have to render it out. You can see it directly in the viewport initially if you want. Really easy to turn on. You go to options and you just go down to stereoscopic just here. Turn that on. And hey presto, we have a merged stereoscopic image for anaglyph viewing. So if you had the red and cyan glasses, you should be able to see this looks kind of 3D. Now there are different things to bear in mind when you are playing around with stereoscopic output. So the first thing is that the view that you're looking at has nothing to do with the rendering. If I hit the render button now, it's not stereoscopic. So bear in mind the view is purely for previewing your scene. So when we've got that on, you can change how that is done by going into configure. So options, configure, and new in R13 is there's now a stereoscopic area in perspective, into the viewport, and you can turn that on or off. And you can also link it to your render settings though, so if you don't want to get too confused and you want to set up your rendering of the stereoscopic output, you can link the two together. Sometimes you don't want to do that. For example, you may be outputting individual channels to go to a shutter solution, but your monitor may only be able to view, for example, anaglyph with a pair of red and cyan glasses, but you want to check what the effects are like before you output it. So you can use anaglyph for the monitor, shutter for output to rendering. That's up to you. But if you support any of the other ones, you can move to those. So you can have interlaced, shutter, side by side, and you see that the viewport will automatically change to show you these solutions. There you go. But if you've got a standard monitor, anaglyph will give you a good representation. Just get yourself a pair of those specs, which you should have got in the box with R13 if you had a physical box shipped out to you. You can swap the left and the right eye around, or the filters, like so. That's very useful if you put your glasses on upside down or back to front. Or you've got different colour solutions to the traditional ones, or the manufacturer's cocked up and sent you the wrong ones. The wrong colours on each side. Additional parallax is a very quick solution to enhance the separation between the two filtered images, so the left and the right. So for example, 60, we get a much wider separation between the two images. Very fast way of changing it without having to look at your cameras all over the scene. And you can also use different systems for anaglyphs. So there's red, or all these different ones. You can set up custom colours for your glasses if you wanted to get a custom set up. But red and cyan is the most popular. So that's the viewport settings, which is all pretty self-explanatory, hopefully. Which is great. What about the cameras themselves? So the good news is that cameras, when you have a stereoscopic camera, it's called a 3D camera now. There's a little 3D by camera. And the really nice thing is if you have existing scenes with the ordinary camera, which is here, and they're already set up, you don't have to go around and replace all your cameras with the new ones and mess around with all the coordinates. Every camera that you bring into Cinema 4D, whether it's an old scene or a new scene, it will have the stereoscopic option here that you can just change, which is really cool because you can just go, I need that to be a stereoscopic camera now, move to symmetrical, and that camera is now a 3D stereoscopic camera, which is great. I'm just going to delete that camera because I don't need that one because I'm working with one here. And we'll just make sure we're looking through that camera. So we'll just have a look at the camera here. Just move it around into the scene. So there we go. So I've got my 3D camera here. I've got an effect now. Depending on the size of your screen, if you look at that through, if you've got a set of those glasses, this may look comfortable or uncomfortable. It depends on the size of the screen, and there are various different things that are important when you're looking at the camera. First of all, we should explain what's going on. So if we move to a top view, I'll just unhide the scene so you can see what's going on here, the environment. Move to the top view. There's a stereoscopic camera, so you can see that it's actually, there's the center of the camera. So if we had a mono camera, I'll just flick to mono. Of course, that's dead center of the camera. When you flick to symmetrical, they're offset from the center by an amount. In this case, 6.5 centimeters separates the middle of one camera to the middle of the other camera. Why? Because that's the average size separation between your two eyes for most humans. So if you're, that's kind of important if you're dealing with children, you may want a slightly less setting, or if you're dealing with really big adults with really wide eyes, you might want to make that a bit wider. Generally, the wider you make that, the more uncomfortable it is to view, but the greater the depth effect. Now, you can also find that you need to widen it in certain scenarios to get a better effect. For example, if I go back to this, I'll just turn off the environment. That could be too wide or too small. You generally find if it's a very small object and your camera's really close to it, like this drill is pretty small, that the effect is too big with the standard eye separation. So your solution is either scale up the object or lessen that effect on the camera. You can do either one. I'll just scale this up just so you can see. I'll just ramp that up. And then of course you'd move it backwards in the scene, or move the camera backwards. So of course the effect is then less. So I'll just do that. Just that way. So you see now the difference between the two separations is much less, so it's more comfortable to view. I'll just put that back to where it was. I'm going to use the wider than comfortable effect just so you can see it good if you're on a small screen. It should be quite obvious if you put those on, but bear in mind it might give you a little bit of a headache. So we'll just play this so you see, of course, the effect happens throughout the whole animation as it goes around. And we'll just click on the camera again and see what else we've got. So there are different solutions for stereoscopic output, and I'm going to jump to the help system so you can see what those are. So you can right click on anything in cinema, choose show help, and it will normally show the help for that particular thing. And there's basically four main solutions for cameras, which is parallel, off-axis, on-axis and radial. The one you will most popularly use is the off-axis one. Parallel is the traditional one. Off-axis gives you more options, and I'm going to explain why in the next thing. And this is probably the most confusing thing to get your head around: the zero parallax. Now, the zero parallax, remember before I was saying the trouble when you're viewing an image that you want to have perceived depth, so a stereoscopic image on a screen, is the screen is flat. That's different to real life. So you're trying to fake the effect that we get in real life with our two eyes when an object is near or far and getting that perception of depth. So what the zero parallax is that's the plane where the screen is. So it's basically saying at that point things should be flat. So hopefully we can explain this by turning it on. So I'm just going to have this scene. Actually, what I'll do is I'll just turn on the camera. So there's the camera. I'll zoom out a bit. I'll zoom out a lot, in fact. Sorry, so there's the object. So the zero parallax at the minute, it's also a little hard to see sometimes where it is in the scene. So quickest thing is do a fairly big change to it. For example, 150. And I could see it jump there. So I know that's the zero parallax. So often in your scene, rather than type in a number, you probably want to just move it manually. So what this is saying is at that point there, that plane, that particular area should appear flat to the viewer. So if you put something on there, it should appear flat. So you've then got the planes, the near plane and the far plane, and autoplanes. Now, you can work different ways. You can either manually set it up as I am, or you can set up your camera with the defaults, either 70 or 90, and these refer to the comfortable zones when you're viewing stereoscopic imagery. Basically, the more you pop out something towards the viewer, so this side of the plane would pop out, remember, nearer the camera would pop out, the more uncomfortable it is for the viewer to view. So if it's right in their face, a bit like in real life, if I took my finger and pointed it right in your eyes, there is a point where it gets so uncomfortable you can't even see the end of my finger, and obviously it annoys the eyes. So the more you do this, and particularly because we're faking the effect, the more uncomfortable it is. So the general rule of thumb is to get away with the least amount of pop out that you can, but still quite fun for your scene. So you can use the near and the far plane to make it comfortable. Sometimes you may want to make it uncomfortable. You may have a horrible movie where you want to have something really jump out and scare someone just for a couple of seconds, so you may want to have these up really close. But we'll change, so you can see my near plane and far plane are currently way too far away, so I'll change the near plane to 100, so there it is, and I'll change my far plane to 300. Oh, maybe even more than that. Let's just change that a bit more. 500. There we go. So I've got my near plane, my far plane, and the flat plane. So remember, the zero parallax is where everything is flat. Now, the reason why I said before that the most popular is off-axis is the trouble with parallel is the zero parallax really doesn't come into play that much, because all things can do on parallel cameras is pop out at you. So the only things that will appear 3D in here are the stuff this side of the plane. The trouble with that is that's a limited amount of depth that you can have in a scene. When you switch to, and you'll see that here hopefully, if we look, so I just want to make sure I've got a particular angle on. Hang on. I'm just going to play this movie slightly just so we've got an angle that we can view everything at. Maybe there. I'm just going to move the zero parallax just so this big bit at the back is after the zero parallax. So if we look at this at the minute, you can see that the cyan's on the right, the red's on the left, which is fine, but that means that everything appears the same to the viewer. The whole thing appears 3D and pops out at the viewer, and you'll see that if you put on your glasses. So to get a better sense of depth, you can use off-axis. So I'll jump into my camera. There we go. And you will get more control on it. So hopefully you can see this bit in the foreground, the blue is on the right and the red is on the left. And in the background, the red is on the right and the blue is on the left. And this gives the illusion of depth to the person viewing it. And we can also see at the minute this is quite a low effect that we're getting with the parallax. So we could increase the eye separation. I'm going to do that just so you can see a little clearer what's going on. That'll be probably quite uncomfortable to view. And now as the object spins around, you should see as it goes into the background, and see there, that's roughly where the zero parallax plane is, so the difference between them gets very tight. So it appears flat at that point, and at the background they've swapped round. So this really helps get the illusion of depth, which is why people use off-axis. Now some people will use on-axis or radial, and generally the advice is to use those if you know what you're doing. Otherwise use one of these because you can have less problems with off-axis but still get quite a good range of solution. So it's up to you if you want to use one of the other ones, but they're mainly there for compatibility with other applications. So hopefully you understand the zero parallax now and the reason to use off-axis over parallel. That in a nutshell is the solution and the main things you need to do to get the stereoscopic output done. Waiting. Sorry about that, problem with my mouse. The final thing that you need to do is the render settings. So inside rendering, stereoscopic output is here. We turn it on, and then we have different solutions. So merge stereoscopic image is where you can have a merged stereoscopic image, funny enough, which is where you have the complete solution on one image. So that's an ANAGLYPH image like we saw earlier on. And it will ask you in the render settings what mode you want. So ANAGLYPH was the first one I showed you right at the start of this tutorial. You've got side by side or interlaced though. You can have additional parallax with that if you want. You can also have a non-stereoscopic image outputted at the same time. Useful for an animation if you want two versions, one stereoscopic, one not. You can tell it to save it in a folder. And then there's different methods. So any of these things you're not too sure on, just right click and say show help and it'll tell you the exact things. Normally the defaults are absolutely fine and the recommended ones anyway. Individual channels is if you're going out to something and you want to have the specific channels. So typically for a shutter solution the default is 2, but you can up that, like we said before, to however many channels you want. And the nice thing is if you send this out to something like After Effects for final compositing, those channels will come out correctly named, so they're really easy to bring into the likes of After Effects and have those ready for further compositing. And you can use the folder, everything comes in correctly named, all lovely. You've also got individual channels and a merged image if you want, or single channels. So they're all pretty self-explanatory, but you basically turn them on, choose your render. So if I just choose merge, for example, go to rendering, it'll output the image just shrink that down because this is quite a big image. And I've got it on animation, so sorry, that's my fault. Let's go back. We don't want to do that. We want a single JPEG. Stereoscopic merged. Let's try that again. So I'll calculate the image and then the offsets, and then it will combine them. There we go. And that's it in a nutshell. That's what you need to know about stereoscopic output. That's the basics. So from here you want to consider your screen output size. If you're just doing little stuff for local use, that's not so much of a consideration. Just sit and what ideally view on the screen that you want other people to view it on, to get the right settings, work from the defaults, and go from there really. But hopefully that gives you a good overview of how Cinema 4D is set up for stereoscopic workflow. Hope you enjoyed it.